Yeah, so I'm Ken. My name's Ken Wheeler. And that is Ken_Wheeler on Twitter. And it's just a bunch of trash, but you guys should follow it. I'll wait. Good. Okay, awesome. Oh, yeah. Good, okay. Excellent, then we're all on the same page. And I work at a company called Formidable, which is like a JavaScript consultancy based out of Seattle, but I work in New Jersey because I'm an HR liability. It's good, remote work. And they do a lot of Node, React, GraphQL, stuff like that for bigger companies. So we get to do some pretty interesting projects. And also do quite a bit of open source, of which I am the director there. So it's a fancy title for getting a little bit of time to do whatever I want. So that's cool. And I'm here today to talk about ReasonML. Has anybody heard of this? Can I see a show of hands who's heard of ReasonML? All right. Can I see a show of hands who's a JavaScript developer in the room or knows JavaScript or plays with it? Reason? Okay. All right. Yeah. Good crowd. Yeah. So I'm gonna first frame this by making the case for ReasonML by talking about it in the context of building sturdy applications with JavaScript. All right. Let's talk about how to build some sturdy applications. Can I see a show of hands who likes sturdy applications? Who likes their app sturdy? What? Who are these people who are not raising their hand? Kidding me? So what makes an app sturdy, right? Pretty small baseline, right? It works, right? That's a big one. Is that it works out of the gate. You'd be surprised how often that doesn't actually happen, and it doesn't get caught. Ideally, errors are caught at compile time, right, as opposed to runtime. And if you have runtime errors, they're handled, right, and the whole thing doesn't just shit the bed. So we're talking about this in the context of JavaScript. So let's kind of examine that JavaScript context for a minute. I mean, JavaScript is an interpreted language. It is dynamically typed, which leads to things like type coercion, right? Which in some places is fun, and other places is not so fun. And a lot of devs who use type languages kind of scoff at JavaScript, and that's a lot of that is like the roots of said scoffing, because it can take away from general app sturdiness, right? So how can we make this better? How can we work around what could be described as a fragile base? So let's talk about some lines of defense that we have now that we can use to make these apps sturdy, right, in JavaScript land, right? So first and foremost is linting. Linting doesn't really make your app sturdier from like a writing your code perspective, right? It does like enforce best practices and annoy the shit out of people a lot of the time if it's more of like a style knit sort of thing. I think that's where a lot of it gets the bad rap, is when you're doing like useless linting. But the cool thing is that it statically analyzes your code, right? In order to do this linting, it has to go through, right? So if we head back to what makes a sturdy app, and it works, right? If your lint doesn't run, then your app isn't going to run either. So your lint bails because there's a problem analyzing your code. Chances are your app's probably not going to run either. So that's your first line of defense. If your lint doesn't work, then you're in a good place. You understand that this app sucks at the moment. Next up is Prettier. Can I see who uses Prettier? Hands who use Prettier. If you don't use it, you should use it because it's the jam. I get like the whole like I'm gonna write my code how I want kind of thing, but there's a lot of advantages to it. And if you don't know what it is, so Prettier is automatic code formatter, right? And it enforces a consistent code style, right? It kind of removes the whole bike shedding around like tabs or spaces or semicolons or anything like that. If you've ever used somebody or if you've ever had somebody working with you on a project and you see like the PR diffs and it's bananas because they have different spacing rules than you or something like that, it's super hard to pick out what's actually relevant. Whereas with Prettier, you kind of just see what changed and not any style weirdness. So Prettier also statically analyzes your code, right? And one of the best feelings in the entire world, if you haven't used Prettier, I think you should give it a shot, because when you hit save and you have format on save with Prettier, and you've just written code and you don't really care how you wrote it, you're just like, and then you hit save, and then that shit snaps into place. It's like the best feeling. You're like, it's just like, perfect, and you're like, nice. I had to do like this like code interview thing, and it didn't have Prettier, and I'm typing. I'm like, what is this? Is madness. Yeah, so you should give it a shot. It's cool, right? So, like linting, if you go and you hit save and it doesn't snap into place, you're like, shit, because there's an error in your code. It can't statically analyze it to format it, because you have an error right there, right? So we went over the things that'll just cause straight up errors, right? Which, I guess your interpreter level erroring, where the app wouldn't just run. As far as like just making an app generally sturdier, there's some things that you can do to make it more maintainable and easier to work on and more readable, which, I guess through the people working on it will probably make it sturdier, because they'll have an idea of what's going on. It'll be easier to reason about. Stupid word. The first thing is don't write big apps, right? Write a bunch of small apps. Right? So take your focuses and write them individually as components, not necessarily literal components in this context, but like if you have a feature, develop it kind of in isolation and make it modular to the larger whole. It'll be vastly stabler than if you just have the bias of the immediate application. So you want to develop your componentry in isolation, right? If you develop a component and you have the bias of the app that it's going into, you're like, yeah, but it has to do this and this based upon, this is where it's going to go. But you don't know where that's going to go later, right? So if you do it in isolation and kind of look at it as its own thing, a lot of the time you can make architectural and design choices that just makes for better components, right? And you can explore things like option and prop permutations that you could support. Right? Has anybody ever used Storybook? Can you show of hands? Yeah. So at my job, when I'm not doing whatever the hell I want, I have to do like project architecture and setup for teams. So I'll come in and I'll set a project up and stuff. And one of the first things that I do is set this up, Storybook. So what this does is, if you're using React and you have React components, I think it works for more than React, but if you're doing component-based architecture, it's like a style guide, so to say, but it's like a living style guide. And what it allows you to do is you sit there, and on the left-hand side, it's all the components, and then the little indented lines are the permutations of props or options for said components. And then you develop it right in here in Storybook, right? And you get to see these things in isolation right here. And it leads to a really, really nice development experience for your components. You write better components as a result. And then, if you develop it here and you have these permutations by themselves, right, you get a better idea of what's going on before snapping them all together like Lego pieces into the final application. Highly recommend it, right? And then testing. Who does that? Can you see show of hands? You fucking lie to me. So I was kind of like a cowboy in it for a little while there. I would write tests, but like not like exhaustive tests. And you should write tests, right? So my main point behind testing is that it lets you, and I don't know why I put that in parentheses and didn't like make it like a bigger font, but that's the emphasis there, and others. Right, develop with confidence. So if you're working on your own thing, if you're just going solo, right, you have all the context of what's going on. You have a pretty good idea. You wrote it, you architected it. You don't have to work, nothing else. You're good to go, right? It's all up here, right? But when you work in a team, it's a little bit different. When you're not working on a team and it's just randos on GitHub committing code, you don't know what to expect, right? So if you don't have tests, it's really hard, even if you kind of know what's going on with the project, right? It's really hard to discern whether that's going to work or not. And if you're not the person who started the project, if you're just some person who's like kind of working on it, and then some other completely unrelated person comes in and PRs it, who knows how to verify that? Test, that's how, right? So let's talk about a couple different kinds of testing, right, that you can do to do sturdiness. So I guess the most common that you might see is unit testing. especially for like open source library type stuff, right? You definitely see that there. So I like to use jest for that. And really you just want to kind of cover the possible branches of your logic, any which way the if and else can go, just to make sure you've tied away all the different cases, right? And it's really about verifying that your functions work as they're advertised, right? So if anybody makes an update to that, the test will fail, and then you'll be able to say, hey, is this a valid failure, or do I need to actually update the test, right, for the new feature? And yeah, that's the funny thing about tests is that you can't test. I mean, you can test your test, but it's hard enough getting people to write the original test in the first place. But yeah, your tests are only as good as your tests. Get that tattooed on my chest. So there's another type of testing that I like to use, especially in the front end realm, which is snapshot testing. Show of hand snapshot testing. Oh yeah. So I recently caught something with this, like just the other day, where I had an extra class that was getting added to every single element on the page. Long story, but it was fine. But that might not have been super apparent, right? So what Snapshot does is if you have a React component, or you can actually just like server endpoints, you'll take a render tree or a JSON response or something like that, and you will serialize it and you will save it to disk. All right, so you commit that to your GitHub repo. So when you run your snapshot test the second time, right? The first time it's just going to take it and put it on disk. The second time you run it, say you come back, you do a little edit, right? Time to test it again. It's going to diff the one that's stored on disk against the one that's currently in the running context. And if anything's different, right, you're going to have to verify that. So it's a really easy way to pick up, like you might change like one thing in one component over here, and then for some reason down here you have a different result. So it's nice to catch side effects with that, especially unintended ones. This is what it looks like. If we look here, is this I can't select it with my mouse, just a picture. So yeah, when you run it and you have a bad result there, it'll say the original snapshot in white, ooh, shadow alligators, and then the mismatch in red. Here, it looks like an expiration field, right? Got added to this array of objects on each object. So that's probably valid, right? And then all you have to do is verify it. So you just run jest test and then underscore or dash u, right? And then what that'll do is you're saying like this snapshot is valid, and it'll take that and then it'll replace the one on disk with this. So then this is the gold standard that it'll check against. And the shit's phenomenal. The last one I want to talk about is end-to-end testing. I typically use something like Selenium for that, but these days, has anybody tried Cypress? It's pretty chill. It's good. If you want to do end-to-end testing, it's nice to get people to test it all, but end-to-end testing is pretty nice to have. It tests your app as a whole, so not just like the individual things. You're saying like, it's like a program pretending to be the user and running through it, snap together, right? So when you take all those components that you developed in isolation and you've put them together, does it work, right? You ever see like these unit test memes? Like, I don't know, I've seen a lot of them, but it'll be like some funny thing where the things worked in isolation, but then in practice, what? Yeah, I was in a hotel in Hawaii, and there was one door, right, that like opened this way, but when it was open this way, I couldn't open up the bathroom door, right? It like overshot this one. I made some stupid Twitter unit test joke about that. But that's what it's all about. Sometimes you'll have things in the isolation, you don't see the context, and you put them together, and suddenly I'm locked in the bathroom. These things happen, and then tests are good. So I mean, that's a lot of lines of defense, right? That's a lot of good stuff. But even with all of this, you still can't be sure, right? And that's because of types. Types, if you said to me, between linting, prettier, all the different types of unit or tests, or types, if you had to pick one to roll with, just one, I'd pick types any day of the week. Because most of the time your app shits the bed in production, it's some weird ass type error, right? Usually something is null or something like that. Then you have the less obvious things where you lose $15,000 because of type coercion. It does some kind of weird math thing with like a string and a number. Types. So let's talk about types. Why are types dope? So first off, before you even get into the actual typing, they're self-documenting, which is phenomenal. You can kind of look at shit and know what it's going to do. You know what it's going to accept. That's helpful when writing code. Much like linting and Prettier, it does static verification. And the real winner is type safety. Right? So it will check the types and make sure everywhere in your application where you're doing something that the types match up. Right? You can't send a string where an int should be. Back to the self-documenting piece there for a second. One of my favorite things is if you use VS Code. If you don't use VS Code, what are you doing? I'm joking. But no, if you use like something like VS Code probably has the best TypeScript integration story. It's all right with Flow. It's okay. But don't say Vim. Yeah, it has IDE hinting, right? So if you go and you're starting to write out your code, jQuery $, I'm kidding. You go to hit the period, it'll come out, and not only will it show the possible options there, like what the keys of this object are, but if it's a method and you start typing it, like you'll get a little pop-up that'll say like the types and what it's supposed to go there and whether it's optional or not, and that's really helpful. Like at first it's like kind of noisy, right? But when you're working with like an API that you might not be used to, like I was on a project for unknown company in unknown project, and I didn't know, I had to work with their system rather than write ours. So I went to go use it, and I would have been like scratching my head because it was completely undocumented, but it was all written in TypeScript. So I was able to kind of discern what was going on there and get my work done. So it's helpful. And then if you know what it's doing, then it's just butter, but I digress. The biggest thing is that it gives you peace of mind, more so than any of the other previous things. So I'm real big on types, right? So how do we do these types? There's actually a lot of options. So the first one is TypeScript, as I was mentioning before. TypeScript's been around for a very long time. And only recently has it gotten good. It wasn't that good up until recently. And there's a lot of debate over whether it's JavaScript or not. It's not JavaScript. It's a superset of JavaScript. It's as JavaScript as CoffeeScript is JavaScript. It's a compiled to JavaScript language. Shit's not JavaScript. And then there's Flow. Can I see hands for TypeScript? Can I see hands for Flow? All right, there's Flow. Sorry. So TypeScript is a compiler and a language, whereas Flow is kind of just a type checker. TypeScript a lot of the time will replace like the need for like Babel. Oftentimes you can use them together because sometimes there's some helpful Babel stuff. That wasn't really possible or ergonomic until recently, where I guess Babel 7 added TypeScript support because the other way around was a shit fest. And for the most part, they get the job done, right? A lot of the time, super duper annoying, right? You're trying to add types and things, and you're like, are you kidding me? So this is a TypeScript example with React specifically, right? So you have your props. Back in my day, we used to use prop types, not anymore. So now you'll declare an interface. I know you should put a capital I. Shut up. But yeah, so you have type interface props, name string, an optional checked, which is a Boolean. You do the component generic here, and then if I was using name in a non-string context, it would throw, right? So that's just an example of typing something out in React and in TypeScript, and it's cool, right? But a lot of the time it's really explicit, like having to do this. I get why you have to, but a lot of the time in TypeScript you have to be pretty explicit with it, right? It's not first class, so you feel a little bit of friction, right? They're good, right? But it's frictiony. Another thing is that it's not fundamentally sound. So if you are using TypeScript and you're going to continue to use TypeScript, I beg you to use the no implicit any rule. Otherwise, it's not even worth using. It's silly because, I mean, even with no implicit any, it's still not fundamentally sound. However, if you allow one any in your code base, then you've allowed all the any's. Because anybody who has to get something done is just going to any your shit up, and it's over with. Types have no meaning anymore. There's no law and order. Just Wild West. And the inference is okay. It's not great. If TypeScript is all you know, then you're probably like, wow, this inference is fantastic, right? But if you've worked in other languages where types are first class, TypeScript gets a little explicit at times, and you really got to spell it out for it. And it's another layer of tooling that we have to put on our projects, right? Which gets so annoying because, my entire job is setting up these projects and setting up the tooling because it's such a pain in the ass. So I have to set up, not just the project architecture, but this entire bespoke tooling stack every single time. And you might say like, hey, why don't you just make Create React App? Because clients don't want every single decision that Create React App makes. So a lot of time you'll have a client who's more partial towards Flow or partial towards TypeScript, whatever. So you have to set it up with them in mind. Sometimes the client's like, go ahead. And then you have fun, but that never ever happens. So what if there was a better way? I'll tell you what there is. And it's called Reason. Wow, ReasonML. All right. Does anybody, I saw who's heard of Reason. Who's actually played with this before? No hands. Oh, we're going to have some fun today, and you were going to try it, I promise you. Okay, so let's talk about Reason. Reason is a new syntax and toolchain for OCaml. Does anybody know what OCaml is? You know what? All right, okay. I'll get to that. So it looks that, despite being kind of based on a 25-year-old systems language, it looks and feels like ES6 sort of, right? So if you're coming from JavaScript, it's very comfortable. And one of the things that makes it outside of the syntax that makes it comfortable is they made it a choice, right? They said there is so much developer mindshare around the NPM workflow, the package installation, the script running, all that shit, that they based their workflows around this language in NPM. Right, so that it's familiar for everyone. It's a popular way to do it. It's a good way to do it. So that's how they're doing it here. And you can think of it as JavaScript's typed faster and simpler cousin. You might debate me on the simpler at first, but I promise you. I'll get to that. So back up to that first point, OCaml. All right, let's talk a little about OCaml. I'm just going to stop for a second, and I didn't include this slide, but this shit would have been amazing. I've given Reason talks before, and when I come to explain OCaml, for one talk, I found, you ever just Google something and it's just magic and it just comes up? I wanted to make a joke about an Irish camel, OCaml, right? So I went and I Googled Irish camel, and sure enough, dude, there was this leprechaun. Yeah, it was the best slide, and I'm kind of regretting not doing it. It was OCaml with a question mark, and then it was this camel smoking a pipe with a shamrock. It was amazing. All right, so OCaml. OCaml is a general purpose systems programming language, right? This is not run natively on the web. It's regular systems programming, something like C or something like that. It is an ML family language. Right? Meta language. So there was the original meta language, right? And then there was, I guess, OCaml came from that. So the ML language influenced languages like Elm, like Rust, Scala. A lot of these are derivatives of some of these ideas here. OCaml is a direct influencer of F#, if anybody's ever played with that. Yeah, F#'s the shit. The Reason is the shit. So, but yeah. So it's a meta language. It's from that family of languages, which is very functional and fun. And one thing to think about here is that it's a stable, mature 20-year-old language, right? 25. Well, I mean, I guess ML itself is like 40-something years old, but OCaml is 20-something years old. But a lot of problems have been solved because this has been getting worked on for a very, very long time. I don't know everything. Hold on, let me just time check my shit for a minute. Where are we at here? Oh, I got time. Okay. Yeah, like if you ever like you're like, oh wow, this new pattern's cool, da 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 da, and there's like some old dude at your company who's like, I've been through this shit 3 times, keep solving the same problems, I'm sick of this shit, I'm gonna transition to management. Like, that guy, yeah, this is what that guy's talking about. Yeah, these problems have been solved before, and they're nice, right? It's really well done. But the nicest thing, in my opinion, is the typing and inference story. It's my favorite type setup I've ever worked with in my entire life. The inference is fantastic. The way that it's set up, I forget the name of it. There's a specific word for the type system that ML uses, but it's so dope. Like the point of it is to have the inference that you don't have to type as many things. It kind of just knows, right? A lot of the time. Yeah. That is, yeah, you're right. That was a word. Henley or Hinckley Miller? Hindley Miller, yeah. Yeah, that's the type system, and it is fantastic. So yeah, I am literally suggesting that we write web apps in this. And I'll show you why. All right. First of all, right, so you can make it web apps, but it's also fast native code. If you don't want to target the web, you don't have to. You can write your full stack in this. I have a friend who just released a product called OneGraph. It's like a thing that takes all your service integrations and puts them into one GraphQL endpoint. And he took this and used Reason from the bottom up, did the whole server architecture in Reason, did the whole front end in Reason. So on the native side of things, and which I'll show some demos later, you can do some crazy shit, and it is really, really fast. Like in some instances, it's faster than C. So I mean, it's a legit language, and it also, yeah, it's pretty fast for a GC language. It's pretty ridiculous. So you don't have to worry about, it's not like Rust. Like I've been trying Rust lately, and like the whole like lifetime thing, I'm not smart enough for that shit. So. So what's cool, from a functional language, right, is that it's functional, right, but it has a lot of escape hatches, things like side effects and mutation, which means you can actually put them in prod. Sorry, ouch. And here's a fun fact. React itself was originally written in standard ML. Right? The original implementation of React, when my buddy Jordan Walk wrote it, he did it in standard ML, and he is also the fellow responsible for Reason. Right? He wanted to bring ML to the masses. So ReasonML is being actively developed by Jordan Walk and Cheng Lu and a bunch of other dudes at Facebook, along with a very active community. There's a huge Euro community for it. But yeah, they use it meaningfully in prod at Facebook. Yeah, and the type system is bananas, right? And it's basically ECMAScript 3030, right? And you'll see what I mean in a second, right? Let's take a look at what this looks like. It looks like JavaScript, I promise you, right? So that is ReasonML. That's it. That's all you can do is addition. No. Yeah, so that's valid. That's pretty much word for word what you would do in ES6 for a sum function. I have the add function, but in a different one, it was sum, and I was like, it's a little sum function. It's a little sum. It's the fucking worst joke. But yeah, it's identical, right? So let's explore some language features, right, that are a little bit different, and we can start with this one, right? Wow, right? So much like before, we have one of these functions here, but a couple things are different. You're seeing some syntax that might not be so familiar. What's going on here? Okay, so this right here, see this tilde before name? That is a named argument, right? So if you are not a fan of positional arguments, you've resorted to objects. Keep your arity down. You have named arguments here. So this is name. So it doesn't matter the order in which they're specified. You can kind of just name equals Ken, and it works. You also might be wondering what this is all about. The old double plus. That's string concat. And some of the operators are kind of funny like that, where say I was adding two floats together. It's actually a plus dot, plus period, right, for the float addition operator. So there's type specific operators that are a little funny, but that's one of the first things. So let's talk about records. Right? A lot of the stuff that we do is based around objects. Reason not only has objects, right, but they have records, which are like immutable objects that you use all the time. So here is a record, right? It looks like a regular ES object. May, age 33, right? You see up here this type definition. You cannot create one of these records without a type definition somewhere in your project defining the shape of that record. It won't let you. It'll say that a type wasn't found for this record. So it makes sure that, but also you're seeing that we don't have an explicit thing saying that this is this, right? Remember we were talking before about inference? It kind of just infers that. It knows that. It sees this shape, right, of age, int, name, string, and it just knows. It says, hey, what do we got on the books? Well, that's a person. So here, this is right. You know, if you've done TypeScript, this probably looks pretty familiar, right? It's normal type stuff that you're used to. So yeah, that right there is a record, right? And you use dot access. If you do an object, you have to do 2 pound signs instead of a dot to access keys on an object. Objects are mutable. Records are immutable. Right? So let's get into what is completely different. And there's 2 things that I want to talk about that are super duper different, but it's such an enhancement upon regular JavaScript writing that every time I go back to writing JavaScript from writing this, I'm absolutely disgusted and sickened because, God, this is so good. So variants, right? This is a variant, which is at the same time a type and a data structure, right? And on its own, just like this, right? Marginal usefulness, you know, it's kind of cool, right? It's like a TypeScript enum almost, right? If you use TypeScript enums. So I say type status, right? And you can have idle, loading, or error, right? And you know, it's not saying like that's equal to like a string called error or anything like that. Like it's just that. It's like a constant or an enum, sort of. Bear with me. Right? What's cool here is that it accepts arguments as well, right? So, you know, amount. See this right here? We have amount. This should actually be amount $, but I digress. We say let $amount equal $, and then with the argument, right? So that'll create that variant with that value. Again, you're probably sitting here scratching your head wondering what's going on, where's the utility in this? So this gets put together with pattern matching, right? And variants and pattern matching together are the shit. When you're writing ReasonML apps, when I first started writing ReasonML apps, right, I was kind of writing them like JavaScript apps with ReasonML. And one reasony dude that I know like took me aside and he's like, listen, check this out. He's like, here's how to do this reasonably. And I was like, get the fuck out of the room. but he was right, because when you write it in the Reason way, it's fantastic. So pattern matching, right? Let's say we have this amount is 5 here, right? And then you have a switch, much like you'd see in JavaScript, like a regular ass switch. Except this is a little bit different. What this does is it does an exhaustive pattern match on whatever this could be. All right? So here, I say my first condition to match on, my first expression, is going to be amount when amount is greater than 5, right? And then we return greater. So result would equal greater if this was greater than 5, right? If amount, which equals 5, does in fact equal 5, then it'll return exact. And this underscore is kind of like a default. It says like if it is equal to anything else. So if this default's not there, what this will say is that there was not exhaustive enough pattern matching taking place, and it'll throw an error because you haven't exhausted the possibilities. And going back to the original thing with the sturdiness, this language level enforcement of exhausting all the possibilities and handling all your business leads to remarkably sturdy apps. So before I was talking about how, a lot of the time you get a runtime error, it's because some shit was null. Well, there's no such thing as null in Reason. There's no such thing. In JavaScript, if you have like an undefined or null value, there's like 9 different things that can be. There's 9 different ways to express that. Here, there really isn't a thing. There's a thing called an option type. And an option type is a monad. And what it does is it has the concept of none and some, right? So this type is a variant type. It's a built-in variant, like we were looking at before, the variants. And it has 2 states that it can be in, either none or some. It doesn't have some shit, or it does have some shit. So here we have this list of things, right? We have this function, list of things in here, and then we do a pattern match on list of things. And on our pattern match, we're going to look for none or some. It's automatically going to infer from the use that the shit is an option, because if I come down here and I don't put this sum on here, it's going to error. I'll talk about that in a second. But if there isn't anything, we return an empty array, or list. That's what they call it. Here, if we do have something, right, you have the variable here, right? You return whatever that is, presumably a list. And then here's another thing that I really, really like about Reason, which is the pipeline operator here. So if I had JS log, right, we just do the switch and whatever it is, put that to log and it'll log it out. So you can do that to kind of do this like. It's like a foldle. So yeah, back to this for a second. Like this is just a list right here, the 1, 2, 3. If you just tried to pass this in here, this is going to throw an error, right? Because it's expecting an option type, right? It's not expecting a direct list. It's saying, this may or may not exist. So you need to pass some and then that list so that this is a valid value. It's one of these 2. The possible states of the option type. So the pattern matching exhaustiveness along with the absence of null makes it really hard to throw runtime errors, short of some really weird thing that isn't typed out. Here's where shit's going to start getting a little crazy, and that's modules. The module system is a lot different than anything you're used to if you're writing JavaScript. So there's no import or export. In JavaScript, you might import React from React, export default, whatever. Nothing, right? You have just module scope throughout your entire project, right? They're like mini files or names. Like it's more like a namespace, probably, right? Every .re, that's like the extension that you use for these. Every single file is a module that's available everywhere else, right? So if you have like home and posts, and you're in home, like capital P posts is available by default in home because it's part of the same project, right? You're never importing, right? It's just there, right? It just kind of knows, and it's compiled, so it can handle that. It's not like you're like not code splitting or fucking tree shaking or anything like that. It just knows, right? So it's all available to you at all times. Beyond that, you can nest these modules. If you're inside of one of these files, you can create a module right in there. Submodules and do nesting. And I'll show you the syntax for that in a second. This is like an example of all the things in an app, right? All the files that are actually modules. A lot of these are actually React components, and I'll show writing Reason React in a minute. But it would be like you never have to import your components. You can kind of just use them. Huh?
Is it top down like a chart?
What do you mean?
Like you can't call something from below, from above?
Yeah. Yeah. So yeah, your scope in an individual file. Yeah, it's like that.
But also between files?
No. It's it doesn't matter the order of the files there. If you're inside of the actual file, like it doesn't like hoist or anything. But yeah, it doesn't matter. Because it's usually alphabetical, so it doesn't matter there. So let's kind of look at this, right? So say we have a test.re file right here. And if you do a let definition anywhere in that file, and I say let module property equal thug life, then in index.re, and I say print endline, and then I just say test, capital T, test.module property, it's going to print out thug life because this is just available because it's in your project, right? This is a nested one, right? So here in test, right, you create a new module, right, called nested, and then that's like a scope here. In between these lines is a scope. You say let handsome fellow equal Ken Wheeler. Print endline in here, test.nested.handsome fellow. Sure enough, it's Ken Wheeler. 10 times out of 10, am I right? Here's a cool thing, right? So in addition to those kind of just being open there, right, you can actually have this open keyword that I wish we had this in JavaScript. This shit is so cool. It's like if you have this test module, right, in a different file, you call open on it, and it basically like takes it and just spreads it out inside of your file, right? It takes all the interiors and then just pulls them up to like top level scope, right? So it just dumps the contents of that shit into scope, and it's fantastic. So if I just open test, I don't have to do test.nested, I just do nested.handsomefellow, all right?
What if you had a nested module inside of the index? Would they run on top of each other?
What do you mean?
Like if you made...
Name the same thing?
Do what?
Named the same thing?
Yeah.
They wouldn't let you do it.
When they did.
Yeah. I mean, if you were to do open test and test had like utils, and then like you had another thing that was utils,
Right.
it would flag you for a collision.
Huh.
Yeah. So here's a cool thing. This right here, how to kind of avoid that if you need to. So this is a thing that is kind of foreign to JavaScript. When you have like these modules, right, it knows that these are modules, and then you can do dot and then parentheses, and anything in between the parentheses is limited or includes, right, the scope of this, right? So we have nested, right, which is coming from test, but we have nested. And it kind of just like in here, if you just call handsome fellow by itself, right, you're operating within the scope of nested in between those parentheses. So that mitigates a situation like that. So that's cool, that's helpful, right? Last thing I'm gonna talk about before I do some examples are bindings, right?
On that last one, since the code was inside parens, is that only limited to a single expression, or can it be multiple statements?
Oh, it can be multiple statements, yeah. Yeah, anything that's in between those parens, yeah, it's not evaluating that as like an individual expression in there. It's not like an argument, even though it looks like an argument. Yeah, so I've played with a couple different compiled to JavaScript languages, and one thing that I never really liked was the actual interop, right? Because like you have the stuff that's like written from the gate and it's cool, right? But when it comes time to put some shit into prod, you're either working with some proprietary library, or you're working with some popular library that has yet to have bindings or typings written for it, and then it's time for interop. And that's when you're like, are you kidding me? Even with TypeScript. I mean, TypeScript's been getting better recently, but like a lot of the time, like you'd be like, oh yeah, let's pull in, this thing that we need for this app. And you're like, there's no types. Oh yeah, my fucking entire afternoon. And then you just hate TypeScript until you get it working again. So the binding story is actually really cool. I'm gonna explain this and the other thing really quickly. Let me time check because this is a little bit of a sync here. Okay, I have 15 minutes, so I'm going to be quick on this. All right. I've said before that reason is a syntax of OCaml. That's because OCaml has this thing called PPX, which is syntactic extensions built in. All right. So imagine if JavaScript had Babel built in. Right. That's essentially what's happening there. So you can extend the syntax any which way. My buddy Jared very recently wrote what is essentially like a Lisp language that, it's like Reason, but it's like Lisp. It's like, paren hell. He wrote that as a PPX, right? So you can go bananas there. Now, on the other side of that, when you're taking, you've made it the OCaml, but you would then want to make that into JavaScript, you use a project called BuckleScript, which was developed by Bloomberg. You see OCaml getting a lot of play in finance and fintech, right? For like HFT and all kinds of stuff like that. So Bloomberg had some OCaml shit that they wanted on the web, so they wrote this thing where it takes OCaml and transpiles it to JavaScript. And a lot of the time that code is faster than handwritten JavaScript. It's really dope. But what you're about to see here is the bindings to go in and out of JavaScript if you're working in the JavaScript sphere. For native, this doesn't really apply, right? You'd probably just do a PPX, or you do some kind of like C module or something like that. But here for buckle script, right? What it does is it'll bridge your JS to Reason, right? And it keeps your type system honest, right? If you're bringing things in that aren't Reason, that are regular as JavaScript, right? You have to be very strict about how you're typing that and be certain, right? You have to keep it honest, otherwise your type system is no longer sound. The cool part about it is that the way that it's set up, it gives you the opportunity to rethink your APIs, especially with all these cool new language features that Reason gives you, right? So let's take a look here. This is a GraphQL tag, right, which will build like a mini like AST thing out of a string of GraphQL. So here, right, you have a string. Well, this is like an array of definitions, the definitions of the AST nodes, right? But you call this, you're gonna see this if you start doing this a lot. It's a buckle script directive, right? So this says for the module GraphQL tag, which is like npm installed in your root directory. So you have GraphQL tag. You're gonna say external GQL, right? So you're going to call this GQL and then type it, say it takes a string and returns these definitions, right? Then down here, what you're exporting from GraphQL tag array is this GQL function that's written in Reason, right? And what you're saying is for this query, which it kind of infers it's a string, return this function that you're kind of bridging here, GQL query, right? And that's all there is really to it, right? It's just a simple type definition. To bridge between the two, right? And then you would use it like this. This is the syntax for a multi-line string, right? It's like brackets and a pipe. So that's how you would construct your query, right? So let's look at this, how this actually works. I have 13 minutes, and I intend to show you. Yeah, so we're in Reason app. This is Reason React right here. I'm gonna have to bump up my code for a minute. Yarn start. Okay. You're probably seeing BS raw and BS module here. Oh. Yeah, so this is like a super simple starter kind of thing. Right? This has a list that it prints out, and it has like a counter, and it's using React. Wow, a counter! What a novel example. So if you're doing JavaScript and you're in like the context of Webpack and you do like the imported resources like CSS, that's where you're seeing this this like BS raw tag. It's saying do a raw evaluation of JavaScript. So here I'm saying require app CSS, right? It's a multi-line string here. It's a fancy ass eval, essentially. Here this is another thing, an accoutrement that lets you import an image, an SVG into. But I digress. So they wrote React bindings for Reason, and they are bananas, right? If you look at the React Future repo and you look at like what the API is, it looks a whole lot like this. So the opportunity to rethink the API, these guys really took the opportunity to do that with the Reason React bindings. It's completely different from what you might see in React. Like if I was going to do something like this, right? You'd have like class, what is this called? App extends React.component, and then in here you'd have render, return, and then whatever. In here it's a little bit different. When you have a module like app, right? Component and make are obviously like app.make, right? And that's kind of what gets called there. So you can think of make as like your export default for your component. This kind of constructs like the component internals. You say let component equal Reason React stateless component, and you give it a name, and then you just spread it, right? It has destructuring and spreading like ES6. So here, as part of this record, right, we're spreading component into here. So it's saying make it mostly like the stuff that came out of this, and then kind of extend it with this render. Up here we have a named param, which is a prop for message. The children prop is not used, so you do this this underscore prefix, and that that tells the compiler to chill, right? Because otherwise it's going to be like, children wasn't used. But if you do that, you could say, you know, it's required, but it's not used. Same thing here with self. Self is kind of like this context in JavaScript. So that gets passed around so you can call things. It's not really used here, hence the underscore, but I'll show you where it's used in a second. So one thing that's going to piss you, so normally this is really, really terse and, you know, dope to write. But one thing is going to piss you off. I promise you it's going to piss you off. And then if you write enough of this, it won't piss you off that bad anymore. This right here. So this is OCaml we're writing here. This isn't like JavaScript in the context of HTML. So you can't just have free floating text. So what you need to do here is call reason react string on any text that's coming in. You need to explicitly cast it to string for it to create a text node element. So anytime you use a string, you have to do that. So that's kind of annoying. You could kind of just open reason react up there and then just call string around it, but I digress. Let's take a quick look at like two simple examples right here, the counters, right? So one cool thing is it kind of has like Redux built in. Here I have the state type that I create, right? Count is an int. Then I create my actions, which are a variant type, increment and decrement, right? They're just, you know, not really, you know, in Redux you might set it to like this elaborate string setup. Here it's just a variant. This is a little bit different because it's a stateful component. We construct it with reducer component and then spread that in. And then we do a couple things because it is a stateful component. First we set an initial state, right, and we return count 0. If you try returning this without defining this type up here for state, it's not going to be very happy. Then in our reducer down here, we pattern match on the action that got passed to the reducer. And then we call this reason react update, which is kind of like your equivalent of like a set state sort of. And then if you want to actually call the reducer, you have to say self.send. So self has state, self has props, self also has send. So it would be like having like Redux dispatch built in. And then you call it with the actual variant type. This picks up. And what do you know? You're just counting your face off, having a good time. Lists were kind of nuts because lists are set up very differently. This is not a list. This is an array, right? Arrays have the pipes on the inside there. I just went with an array here because otherwise you have to cast a list to array for it to be usable here. So I'm already calling reason react array. So here we have items 1, 2, 3, 4. This is a regular component. This is what it looks like to render a list. Right, you have your evaluation parens. In regular JSX, this is like brackets, but it's parens in here. And I have items, right? I pipe that to array.map item, right? So I map over it, wrap them in an li, cast the item to string. Then I pipe it to reason react array, which is like the element creator, much like reason react string. And then you have this here, and you can do, you know, any variety of transformation you want to do here. All right, so that's some basic reason react. That's it used there. That's cool, but I wanted to show some other stuff that's kind of chill. So this is all like in the context of like a Webpack-y kind of setup. This is actually a create React app scripts. There's this thing I want to show you. If you want to get started with this really easily, the easiest thing you can do is go to Replit, replit.com. If you haven't heard of it, it is the shit. My boy Amjad made it, and it supports all kinds of stuff, but it also supports Reason React. So this is probably the easiest way to get set up. This is the second easiest. If you like Create React App, you ever play with that? This is just Reason scripts. So you would call Create React App and then just do the scripts version Reason scripts. And that's going to scaffold out a Reason project for you to get started with. You don't have to worry about the build system or anything. But for these ones, you're still kind of relying on like Webpack and all that stuff and like the whole JS ecosystem. I was telling you before about why it's cool to write Reason. We only have a few minutes left here, so I want to really drive this home, right? So it's a cool syntax, it's got cool features, writing your shit's dope, your apps are sturdy, right? But I never really proved the point about it being fast. About when you're not just writing Java. You know, investing in this language isn't just for JavaScript. It's for the native side of things, right? If you want to write like really, really fast, cool system shit as well, and what that means, and what the future of front-end development could mean if we were to invest in this properly. And I'm going to show you right fucking now. Okay, so this right here is reprocessing. It's a port of processing in ReasonML. right? It's all NPM based, right? But it's not using any of the JavaScript bundlers. You see this right here? This is OpenGL, opened up in a system window, right? And you can drag it, pull it around, right? It's a cube, right? We're having fun here, okay? You see this right here? There's no React here, right? It's just, you just open the namespace right over here. You have some state, right? The state kind of gets updated as you're doing this. It runs on a loop, so you have a setup and draw gets called on the frame rate, right? So anything that you do in here, it's kind of just like immediate mode rendering. So I said it was fast. All right. Watch, I'm gonna hit save. I'm gonna hit save as hard as I can so you can hear it. Yeah, it's a little bit fast. Wow, that's a bad color combo. How about that? We got white. All right, let's go back to here. Let's make this square a little bit smaller. Oh, what the fuck did I just do? That's what happens when you're out here clicking horde. God damn it. No, right here. Yeah, wrong one. Yeah, so it is the hot, oh, okay. The hot reloading is near instant, right? Because this whole system is set up all through a whole Reason toolchain. It's all kind of like JavaScript. So when you're sitting here, like you have hot reload in React. Oh my God, it's like a 4-second ordeal. You know, you're sitting there and it's like, and then you like kind of like jankily updates. It's like bullshit. This is like, are you kidding me? This shit is instant. It's so fast. Okay, so reprocessing is kind of cool. You might say to yourself, like, wouldn't it be cool if you could build a game with this? Yes. Yes, it would be cool. Yes, indeed, it would be cool. So I did. I started one. Please fucking work. Yeah, it's tight, dude. It's called Top Speed 2069. It's got sound and everything. Right? So it turns out I'm not smart enough to do like AI obstacles. No, I'm just kidding. I didn't have the time just yet. But like, yeah, like this is all just running in GL here, right? So here's not the cool part about this. Okay, I have 3 minutes left, and I'm going to show you what the cool part about this is. Right? So I mean, wow, holy shit, we can make like these like WebGL or OpenGL games on native platforms with this JavaScripty language. Sure, that's cool, right? Yeah. Let's see, what do we have here? Okay. Yeah, so check this shit out. It just compiled it to WebGL. Yeah, with almost the same performance. Okay. You know what's even crazier? So you've probably heard of like React Native, right, and how that targets iOS and Android. But it does it by interpreting JavaScript on a thread and then doing it. So if we hop over to the package.json here, so this can target the web. This can target native desktop. And wait, are we in the right one? No, if I come over here. So this, I don't have the demo ready for this, but this actually compiles to native Android and iOS apps. So if you were to create a game in this, it's a desktop app, it's an iOS app, it's an Android app, and it's a web game, right? Because that's how versatile it is. And it's fast as shit. That's all I got. Thank you, guys. Open for questions if anybody has any.
What was the thing that enabled you to do all the platforms?
That's reprocessing cross-platform.
How do you debug for web? Like you're right a while ago you were clicking, right? You're trying to debug.
There is a debugger, but it'll also it'll spit out. Let me go back to this one over here. I think they're working on actual source maps, but the buckle script that gets sent out, I'll usually look at the buckle script. So the error will source map back to this buckle script right here, which I can read and see kind of where that's happening. And then, you know, if I mean, you know, you can console log like everybody else. But if you want to step debug, you're going to be step debugging through the generated buckle script. Thankfully, this is the outputted code, right? This is what OCaml compiles to the JavaScript. So it's pretty readable in my experience. So if your source map comes back with it, it's going to be to this and not the minified version. It'll come to this, and then from here you can kind of derive where it's coming from because it matches up. It's like function make, right? So you can do it from there. They're constantly working on a better story for all this, so debugging will probably get a lot better. There is a Chrome extension, but I haven't used it extensively enough to recommend it. Any other?
Is the like discoverability story dope like in the IDEs, like when you're
Dude.
you like find all references to a record because you're not specifying
Yeah. You know what?
How do you know what?
Yeah, I'm gonna try and throw an error real quick. Where was which one was that? Is this it? All right, yeah, so like, whoop. That give me any shit about that? Oh, it didn't. Yeah, let's say,
Like you had that record type. You know how you were saying it's like not as verbose to have to declare it as long as it's somewhere.
yeah, no, it'll just look through.
Like how would I find out what that is? Can you like show the let you?
Yeah. So if you hover over something, it should say where it's from. I don't know why my hovers aren't working right now. Oh yeah. Good call. Is that it? Merlin should do it. I don't know why none of my hovering is working right now, but usually if you hover over any of this, you get immediate feedback of where it's from and what it's extending, all the inheritance. You know what? No, another cool thing? It formats the shit for you. So it has pretty printing built in. A thing called reformat, but it's refmt. Yeah, so that's where Prettier came from. The folks who wrote Prettier were inspired by this reason reformatting, and they wanted to bring that to JavaScript. So a lot of people who are frustrated writing JavaScript right now after having been in this absolute heaven and then having to go back and write regular ass JavaScript, much like myself. You're seeing a lot of these ideas get brought back to JavaScript where they're trying to get back on the level that they were there, until this is prime time. It's phenomenal, and they're working on it really hard. And like for example, like React Native, there were bindings for React Native where this would go to JavaScript that was then interpreted on the thread, right? It would output JavaScript that was just React Native JavaScript, right? But they're working on bindings right now that go directly. So it kind of bypasses the whole JavaScript interpreter thing, and they're writing bindings that go directly to Cocoa. So that shit should be, yeah, and then the native devs can't complain anymore about JavaScript. Then they can just complain about functional programmers. It'll be cool. Anybody else? All right, let's go drinking.